Aloha, everybody. This is the first part of how to compute limits. Okay, so in the first part, I'll go over the common algebra type of calculating limits, and then we'll go over the other types in subsequent videos. All right, so first, we have this trick called direct substitution, or just plug it in. That's the method here. If your function is continuous, then you can just go ahead and do a little plug-in. Okay, what I mean by that is when you have a problem like so, there is no issue with x being 5, right? There's no issue with x being 5, so we can just go ahead and say the limit of a quotient. We're applying the limit rules here. Is limit of a quotient is a quotient of the limits, and then limit of a sum is a sum of the limits. So you are able to just go ahead and use those rules to say we're just gonna go ahead and plug in the 5 where x is, and you are able to calculate the limit that way. Now the point here is continuous function. So we'll go ahead and investigate what it means to be continuous, but the point is if there's no issues with x being 5, we can just go ahead and plug in that 5. Okay, the next algebra trick that we can use, and it's very useful here in finding limit, is factoring. Okay, so if you have a quotient and you need to cancel something out from the denominator, well, we'll go ahead and try factoring. If you notice, the numerator is the difference of 2 squares, so it has an x plus 2. So you then recognize, hey, I see something on top and on the bottom but that are the same, so maybe I can go ahead and factor. And yes, when we factor, we are able to divide out the x plus 2. And notice here, when you do divide out x plus 2, when you have division, you can only divide if that factor is not 0. So you would say, well, I can only divide if x is not -2, right? But when you are taking the limit, the definition of limit says not necessarily defined at x equal to 2. X does not have to equal to 2 in order for you to find the limit. So this is an okay thing to do. And so that will just give you the limit as x goes to -2 of x minus 2, which is the simplified version of your function. Now we can just go ahead and do a direct substitution, and we will get -4 as our limit. So factor to divide out common factors. That's a really good trick. Okay, now next, instead of factoring, you'll go in reversed. Sometimes you do have to expand so that you can cancel. For example, when you have this problem here, when you distribute the x into x plus 5, you'll have x squared plus 5x, and then distribute the negative, right, multiplying by -1. You'll have minus x squared minus 2x, all divided by x, and we will see that this is gone. Everything has an x here, so we can just go ahead and divide by x, right? So 3x divided by x is just 3. The question here is saying, when x is approaching 0, where does 3 go? Well, 3 is 3. So the answer to this limit is 3. So expand so that you can cancel things out. Next, common denominators. Well, when do you need a common denominators? Well, you do that when you have fractions, right? So when you have limit of fractions like this problem here, you can factor the denominators so that we can realize the least common denominator would be x minus 3, x plus 2. That's our least common denominator. we go ahead and get that common denominator, distribute, multiplying by 1 to get that common denominator, right? So you're going to multiply this first fraction by x plus 2 over x plus 2, which gives us this part right here, and minus 5, which is the second numerator there. Simplify to just be that, and we can see that this factor x minus 3 divided by x minus 3 is 1. So really you have limit as x go to 3 of 1 over x plus 2. It is nice that this got canceled out so that we can go ahead and do a direct substitution. Plug in the 3, you'll get x plus 2. Okay, so that's the common denominator trick. Another algebraic trick would be rationalizing. And you have seen this in one of the videos before when we were taking the limit as h go to 0, right, with the slope of the tangent line. Okay, however, we'll try to do something where h is not going to 0. We'll say, well, let's x go to 3. What's the issue with x when x is going to 3? When x is approaching 3, x minus 3 is approaching 0. So we cannot just direct substitution this x into here. So as I label here, rationalizing is a really good trick. When rationalizing, we are multiplying by 1, right? So what is the 1? Conjugate over conjugate. Again, a plus b times a minus b is a squared minus b squared. Okay, that means you get to square the individual term here, and that is why that is helpful. Okay, that is why this conjugate is helpful. It get rid of the square root individually. So that becomes x plus 1 minus 2 squared is 4. Reduce, you'll just have x minus 3. Oh my God, look at that. X minus 3, x minus 3. And that is why we rationalize. We rationalize hoping that we will be canceling out that x minus 3, because that was the issue for direct substitution, right? So since that is gone, we can go ahead and plug in 3 right here. Square root of 4 is 2. 2 plus 2 is 4. So we really do just have 1/4 as our answer. Pretty nice. Okay, so that is part 1, just commonly used algebraic tricks. Watch the next video, which would be on using one-sided limit.